Hi there everyone, and welcome back to this exponents and surds lesson. And in this lesson we are looking at exponential equations. Now when we're busy with equations, there are a couple of steps that we always follow, right? And we have to remember that if we are busy with exponential equations, we always try and write it as one term equals one term. Always move the constant terms first, then divide with the coefficients of the variable, and then we go and do this red part. Okay, again, always move the constant terms first so that we end up with one term equals one term, and then divide with the coefficients of the variable. That's very important, and I'll show you what this blue words mean as we go through the examples. But then we go over to solving it, and remember we're busy with exponential equations, so these steps are when we have equations that have exponents in them. There are two things you must remember when solving exponential equations. If the bases are equal on opposite sides of the equal sign, then the exponents will be equal. We use this when the variable is an exponent. So if the variable is an exponent, there the x is an exponent, there the x is an exponent, then we have one term. So what we're trying to do is make the bases into the same number. If the bases are the same number, we can just equate the exponents. Great. And the second rule here is when the exponents on opposite sides of the equation sign are equal, then the bases will be the same. So if we have, for example, a variable base, like here x is a base letter, what we're trying to do is we're trying to rewrite this 27 so that it has an exponent. And if the exponents are the same, then it means that the bases must be equal. Okay, so again, when the exponents on opposite sides of the equation sign are equal, then the bases will be the same. We use this when the variable is a base. Okay, great, like here. Now let's look at the following examples and link these blue steps with the red ones. Here x is an exponent, so the variable is an exponent. We use this when the variable is an exponent. What do we use? If the bases are equal on opposite sides of the equal sign, then the exponents will be equal. So what are we trying to do when x is an exponent? We're trying to make this base look exactly the same as that base. Okay, now I cannot make a 27 look like a 9. But I can make a 9 look like a 3 and a 27 look like a 3. And that's what we're going to do. And remember, I can immediately start. There's nothing I can move. There's no constant terms I want to move, nor is there any coefficients, because we already have one term equal one term. And there's no other thing that I can take to the other side to divide or plus, right? So let's rewrite this 9 into a 3. So it will become 3 to the power of 2 to the power of x equals 27 is 3 to the power of 3, and then we have x plus 1. Now that is exactly that, and this is exactly that, right? Okay, so now we are going to multiply the 2 with the x, the 3 with the x, and the 3 with the plus 1. And then we get 3 to the power of 2x equals, we write the base, and then it is 3 times x, which will give me 3x. And then we have 3 times plus 1, which will give me plus 3. Now, the bases are the same, so I can just throw them away. So I'm going to leave these out, and we're going to equate the exponents. So 2x equals 3x plus 3. Yes, you're with me so far. Because the bases now are the same, we can just equate the exponents and solve for x. So 2x equals 3x plus 3. We're going to take this 3x to the other side, and that will become 2x minus 3x equals 3. And then basically we have minus 1x equals 3, and that equals to minus 3, right? Because we are going to take this coefficient, which is minus 1, so it will be 3 divided by minus 1, and 3 divided by minus 1 equals minus 3, and we are done. Great. So How about the next one? Well, this is a little bit different from this one because x is now a base letter, right? And we have an exponent minus 3. We use this when the variable is a base. Here the base is a variable. So when the exponents on opposite sides of the equation sign are equal, then the bases will be the same. So what are we trying to do with this example? We're trying to get the same exponent. So I have to rewrite 27 so that it's in the form of an exponent. So we have x to the power of minus 3 equals, and then we just break this 27 into its prime bases, and that will be 3 to the power of 3. Now, we are not done yet because here is a negative 3 and that is a positive 3. So now what can we do? So look very closely. So here we are going to take the x to the power of minus 3 and we are going to equate it to the following. 1 over 3 to the power of negative 3. Can you remember this? If we have a positive exponent and we take this base and the exponent and we go put it below the line, the sign of the exponent will change, right? Now let's use another definition. So x to the power of negative 3 equals a third in brackets to the power of minus 3. And you remember this definition, right? Okay, great. So here we go. Or should I quickly explain this to you? Yes, I think so. It's always good to show you again. Now, this is exactly the same as that. Why? Because this will become 1 to the power of negative 3 and 3 to the power of negative 3. But 1 to the power of negative 3 is a 1, right? So you remember that the exponent there has to be multiplied with this exponent, and the exponent there will be multiplied with this exponent. And then we have exactly that. So please, I hope you remember your exponent definitions. So now, the exponents are exactly the same. So therefore, x is equal to a third. And we are done. Okay, great. Now, how about this example? And look, this is going to be a part of this blue one because we always try to write the exponential equations as one term equals one term. So in this case, we have one term equals one term. But look, we have an extra number there, right? The extra base number. So what we'll do is we are going to follow the second step of these blue words. Always move the constant terms while there's no constant term here. Then divide with the coefficients of the variable. Now, there's no variable as a base letter, but this is the same as if we pretend this 2 will be a coefficient, because that's basically the coefficient of the 3 to the power of x. So we have to get rid of that 2 first. So then 3 to the power of x equals 54 divided by 2. Okay, and then we will get the following. 3 to the power of x equals 27, and then now x is a variable that is an exponent. So we go to number 1. What do we want to do? We want to make the bases equal. So that 27 needs to look like a 3. So 3 to the power of x will be 3 to the power of 3, and wow, the bases are the same, so we can basically get rid of these two, and then we just equate the two exponents. So x equals 3 and we are done. Wonderful. Now, how about the following example? Again, we have one term, like the blue words say. There are no constant terms I can move. There's no coefficients I can divide with. So now we are trying to look at the variables. Well, here the variable is an exponent. So we want to make the bases equal, which is this whole step 1 there of the red words, right? So we want to make the bases look exactly the same. And how can we do that? Well, basically, I cannot make a 32 look like a 8, but I can make an 8 look like a 2, and then I can also make a 32 look like a 2, right? Okay, so let's do that. So this will become 2 to the power of 3 with the exponent x minus 1 equals, and 32 is 2 to the power of 5 in brackets, and we have the exponent on the outside. Now, we just created an extra sum for ourselves, which is law 3 of exponents. We want to take that exponent and multiply it with the one on the outside as well as that one with the one on the outside. So this becomes 2, and then we say 3 times x and 3 times minus 1, which will give me 3x minus 3 equals. And then the 5 times the x and 5 times plus 1. So write the base, and then we have 5x plus 5. Wow, look, the bases now are the same, so we can get rid of them and we can equate the exponents. So 3x minus 3 equals 5x plus 5. And then we move the x's to the one side, the constants to the other side. So it will be basically 3x minus 5x equals plus 5 plus 3. And then we just continue to simplify. So 3x minus 5x, that gives me minus 2x equals 8. And x equals 8 divided by minus 2. So x equals, yes, you got it, it is minus 4, and we are done. Now, you can always go and check your answers. If you take this minus 4 and put it in the place of x, and you do the same on the other side, you will see that the left side will equal to the right side. Now, wonderful. Let's go try some more examples, and don't forget these blue steps as well as what we're trying to do when we have exponential equations. Now, here are some examples for you to try. Give them a go at home. Once you are ready, resume the video and see if you are correct. Okay, here I go. Now, here my variable is a base. We already have one term equals to one term, and because my variable is a base, we're trying to make the exponents look exactly the same. So I'm going to write x to the power of 3 equals, and so far the exponents are not the same because that's a 3 and that's a 1. So I'm going to rewrite the 8 into its prime basis, so that's going to be 2 to the power of 3, and look, the exponents are the same, so I can get rid of them, and then we know that the bases will be equal. And there we are done, x equals 2. And then if we look at the following example, here something stands out. I don't want to work with decimal numbers, so I am just going to rewrite that 0,6 into a proper fraction, which will be 6 over 10. And then I'm going to continue to simplify it. Well, your calculator always does that automatically, and then you will have the following 3 over 5, right? Okay, then we have another thing here. According to the blue steps earlier, we have one term, but this one has a coefficient here, the coefficient of the 5 to the power of x plus 1. We want to get rid of that 3. So that basically is going to become 5 to the power of x plus 1. And then we have 3 over 5, and we are going to divide it with that 3. Okay, and you can do that on the calculator because we always take the coefficient and we divide with it on the other side. And then we get 5 to the power of x plus 1 equals 1 over 5, a fifth, right? Now, the bases are not the same yet. That's a 5, that's a fifth. But then we know from the definition of exponents, or one of the definitions, that we can rewrite this as the following: 5 to the power of negative 1. Wow, and now look, the bases are the same, so then we can equate the exponents. So x plus 1 equals minus 1, and then we take this constant to the other side, and it will become x equals minus 1, and x equals minus 2. So when x is minus 2, that side will be equal to 0,6. Now, how about this? Again, something stands out. I don't want a mixed fraction. So I'm going to have x to the power of 3 equals, and I'm going to rewrite this mixed fraction into a proper fraction. So 8 times 3, that's 24, plus 3, that's 27. 27 over 8, right? Okay. Now again, my variable is a base letter, so I want the exponents to be the same. So again, how do I make the exponents the same? I can rewrite those big numbers into their prime bases. So what does 27 become? 27 becomes 3 to the power of 3. What does 8 become? 8 becomes 2 to the power of 3. Oh, and look, what is this definition? When the numerator has the same exponent as the denominator, we can basically apply one of the exponent definitions. That will become 3 over 2 to the power of 3, right? Because again, the definition says that that exponent multiplied with 3 will be 3 to the power of 3, and the exponent there, which is a 1 times 3, will also become a 3, so 2 to the power of 3. So that is exactly the same as that, right? And then look, the exponents are the same because that's what we're trying to do, because the variable is a base. So I can basically say we can cancel that one and that one. So x equals 3 over 2, or 1.5 if you want to rewrite that back into a mixed fraction. And please remember your steps, the blue ones and the red ones, and what we're trying to do when we have equations with the exponents. If the variable is a base, we're trying to make the exponents the same. If the variable is in the exponent, we're trying to make the bases the same. Great. Hope to see you in the next lesson. Bye. This is your host Richard T, and thank you for joining us. Please visit our website mathsa.co.za for free guided exam tutorials.